Problem number 6 in the geometry placement test reads, if the central angle measure is 30 degrees, is subtended by a circular arc length of 6 meters, as illustrated here, how many meters in length is the radius of this circle? So we want to determine the actual radius of this circle, given this information here. Well, there's a couple things that I need to realize. I need to realize that the number of degrees in one whole circle is 360. So I can set up a ratio that would say 360 is to 6, that the circumference of the circle, C, is to the length of arc subtended by the 36. So I want to solve this equation for C, the circumference of the circle. I'm sorry, this is 30. This number here should be 30. 360 is to 30 what the circumference is to 6. So I need to solve this equation for C, the circumference, and I get, when I work the math out, I need to multiply times 6. And when I multiply this side, 6 times 360 divided 30, I come up with 72 as the circumference of the circle. So if the portion subtended by 30 degrees, the length of arc is 6, then we know that the whole circle has a circumference of 72. Now the problem is not asking for the circumference of the circle, it's asking for the radius. So I need to also realize that the circumference of a circle is equal to 2 times pi times the radius. And we've already determined that the circumference here, C, is 72. So what I want to do is solve this equation now for R, the radius of the circle. So I can do that by dividing off the 2 pi from both sides. And the 2's cancel, the pi's cancel, and leaves me with just an R, the radius on one side. 72 divided by 2 is 36, and I'm left with a pi in the denominator. So the radius of this particular circle is equal to 36 over